Hey YouTube, this is Brendan with Cusack Prep, and in this video we're going to be discussing how to solve radical equations. Now, when we have a radical equation, we have something with a square root inside of it, or a square root of something inside of it, and that's basically it. That's all that's needed to make it a radical equation. So to solve it, what you have to do is get the radical to disappear. And the way that I can do that is once the radical is completely alone on one side of the equation, I can just square both sides. Now, on the left side, the radical is just going to cancel out with the square. So we're left with 30 minus x. On the right side, in this case, we're just going to have x squared. Now, if you don't recognize this, it's important that you come to recognize this as a quadratic equation. And anytime you have a quadratic equation, you have to bring everything to one side and set it equal to 0. So I'm going to add x, and I'm going to subtract 30 from both sides of my equation. And when I do that, I'm going to have 0 is equal to x squared plus x minus 30. Now you can solve quadratic equations by factoring. Two numbers that multiply to negative 30 and add to 1 would be positive 6 and negative 5. Setting each of these equal to 0 separately, we would find that we have solutions x equal to negative 6 as well as x is equal to 5. But with radical equations, we have to go back and check for extraneous. What that means is that I plug negative 6 back into my original function, and then I plug 5 back into my original function. So when I do the extraneous check, call this an extraneous check, I'm going to say the square root of 30 minus negative 6 is equal to negative 6. 30 minus negative 6, well, that's just 30 plus 6, so this is going to be the square root of 36 is equal to negative 6. And the square root of 36, well, that's just 6. Now, that's kind of an interesting concept because a lot of times we think of plus or minus when we think of the square root. But when the square root is presented to you in the problem, it only means the positive square root unless plus or minus is explicitly written. So the square root of 36 is 6, and that doesn't equal negative 6. So this one would be extraneous. So we can cross that solution off. On the other hand, if I plug in 5, I would have 30 minus 5 is equal to 5. Square root of 25 is equal to 5. And then I would just get 5 is equal to 5. So this one's going to work. So 5 happens to be our only solution for that problem. Let's take a look at another example. This example, once again, we have a radical. So we're just going to square both sides to get rid of it. On the left side, it's simply going to cancel out. But on the right side, n plus 3 squared is not n squared plus 3 squared. Do not make that mistake. Rather, it's n plus 3 times n plus 3. So we're going to go ahead and FOIL. And when we do, we'll end up with n squared plus 3n plus 3n plus 9, which is n squared plus 6n plus 9. Once again, we have to recognize that this is a quadratic equation. When we have quadratics, we bring everything over to one side. So I'm going to subtract 4n. When I take that away from 6n, I'm going to have plus 2n. And I'm going to subtract 8. When I do that, I'm going to have plus 1 is equal to 0. Now this is going to factor into n plus 1 times n plus 1, which in both cases just give me negative 1 as a solution. So I know n is equal to negative 1. But we have to check for extraneous. So I would do the square root of 4 times negative 1 plus 8 has to equal negative 1 plus 3. So 4 times negative 1, that's negative 4. Negative 4 plus 8, well, that's 4. Negative 1 plus 3 is 2. And the square root of 4 is just 2, so we get 2 is equal to 2. So we know that n equals 1 is our solution.